Hi guys, it's Eric here. Hope you have a nice day. And today we're going to solve this daily question. Maximum area of longest diagonal rectangle. So let's look through the text of the question first. You are given a 2D zero-indexed integer array dimensions. For all indices I, 0 is less and or equal to I and less dimensions dot length, and the dimensions I0 represents this length, dimensions I1 represents the width of the rectangle I. We're gonna return the area of the rectangle having the longest diagonal. If there are multiple rectangles with the longest diagonal, return the area of the rectangle having the maximum area. Okay, so I think today's question is very clearly based on the text, right? But we have to check the example first. You remember the example of the Leetcode question is very important for you to understand the question clearly and comprehensively. So we got dimensions like 9, 3, 8, 6. So this one is the length, this one is the width, right? Output is 48. Y is for index 0. The 9 and with 3 diagonal length equals to square 9 multiplies 9 plus 3 multiplies 3 equals to square root 90, which is this result. And for this one, the result is square root 100 is 10. So since 10 is bigger than this one, right? So we're gonna return this rectangle's area, which is 8 multiplies 6 is 48, right? This is pretty easy, right? Okay, for the example 2, we're gonna input the dimensions like 3, 4, and 4, 3, and both of them are have the same length of the diagonal because they got the same calculation, right? It's 3 squared plus 4 squared is 4 squared plus 3 squared. We're gonna swap the order, does not influence the result of the diagonal length. So maximum area is 3 multiplies 4 is 12. So I think that this question is much more easier compared to the last day. So I'm gonna code it directly without any thinking here. So let's check out this one. So we're gonna need the max area and max dog there 0 and 0. So for length and width in dimensions. So this will help us to do what? This one. This one will help us automatically unpack each rectangle into its length L and width W, right? Because Python has this function. And our current diagonal is L multiplies L plus W multiplies W. You may ask, hey, Eric, this is diagonal length. You need to square root this. So think about this question. Why we don't need the square root here? Because the square root function, like even like there's a square root x, is this one x, right? Square root x. Square root x function is actually a monotonically increasing function, right? If if a squared, if a squared plus b squared is bigger, if this one is larger, then we gotta get square square root this result will also be larger, right? This is learned in our high school, I think so. It's concerned about related to the function, the merit of the function. The characteristic of the function is monotonically increase. So this one is bigger, so square root this one is also bigger. So we're gonna only need to calculate the square squared result of the current diagonal instead of the square root here, because this can help us avoid the extra cost of computing square roots. So we gotta get this one current diagonal is this one, and the current area is what? Easy. Length multiplies our width, right? And we're gonna write our if the current if the current diagonal is greater than the max diagonal. Okay, let's try this one because we only need the bigger diagonal, right? If the current diagonal is greater than big diagonal, but you may notice this one. If there are multiple rectangles with the longest diagonal returns the area of the rectangle having the maximum area. So is this single if can cover all the consequences? Think about this question. If we got if we got two dimensions like what? We got two dimensions like let me think. It's for example 4, 7, and 1, 8. What is the squared result of the diagonal? It's 16 plus 49, right? Which is 65. And about this one, 1 squared is 1 plus 8 squared is 64 plus equals to 65, also equals to 65, but which one has the larger area? Oh, of course, it's 4 and 7 because this area is 82, but this one is only 8. So if we meet this situation like this, and with a single judgment, if we may return this one, right? Because if you write this one in front of this one, you may return this one first in our whole judgment. So we gonna get the wrong answer, be wrong answer only based on this single if here. So what we're gonna do is plus judgment function here, like or what current area. Our current area is oh no, not the area. Sorry, our current diagonal is equal to our maximum diagonal, and our current area is greater than our max area. So by adding this one, we can cover all the consequences in our test case, right? So we're gonna assign our max diagonal to the current diagonal. We're gonna assign this value to this value, right? And we're gonna get our maximum area equals to our current area, which means we need to assign this current area to our overloop our max area to update this value, and we're gonna return the max area here. So let's check if our code is correct. As you can see, we passed the test case here, so let's submit here. Okay, so everyone looks fine, right? I think today's question is much more easier compared to the last day's question, but there is a trick here, and you need to pay attention to this one. So in summarize, we solve the problem by keeping track of the maximum diagonal squared, not a square root here. And in case of the tie, we need to choose the rectangle with a larger area, and this one help us avoid the mistake, right? So I think this one is very important in the whole question here. So this is all I want to deliver in this question, and hope you guys remember when you write the if condition here, you need to read the description here. If there are multiple rectangles with the longest diagonal, remember every sentence in the Leetcode is like a hint or tips that can help you understand this question better. So thanks for today and thanks for listening, and I hope this explanation is helpful. So see you next time. Bye bye.